scripting, what actually server-side scripting comprises of, server-side scripting comprises of, and how we manage all the communication, the request, response, and everything we will see now, right? And there are so many server-side scripting technologies in our full stack. So we are going to discuss about Node.js as our server-side scripting technology. So some basic things you need to understand about Node.js. First, let's take an overview because all server-side technologies intention is same. So intention is same. But why we are using Node.js? What is the intention of Node.js? So this is one important concept to understand. Let's see that. Actually, Node.js is similar to other server-side technologies. So Node.js is an open source. It is an open source cross-platform, and cross-platform JavaScript based. It is a based, JavaScript based server-side scripting. Node.js scripting technology, right? Technology. So Node.js is open source. So open source means already we know that means you can customize according to your requirements the library. It is cross-platform. It can run on every operating system device. And it is JavaScript-based server-side technology. That means Node.js uses JavaScript runtime environment. It uses JavaScript runtime environment. It uses JavaScript runtime environment. Actually, you know that what is a runtime? Generally, runtime environment is nothing but it provides an environment where we can build, we can debug, we can test everything actually. So it is a JavaScript based runtime environment that executes on V8 engine. It uses an V8 engine. So that is responsible for usually we call these as runtime engines. Actually, it is an runtime engine. So runtime engine. It is a runtime engine. Usually, the runtime engine is responsible for performing the actions. So it is responsible for performing the actions. So like compiling, like execution, and managing the libraries. So means syntactical errors and all these are identified and handled. So it is responsible for doing all those activities. So we will see thoroughly how this engine is going to work, how it is going to work. So, but before means that we will see once we start working with it. So first you should know why Node.js we are using. So instead of other server side technologies. It depends on the requirements and everything. So you can use Java, JSP, PHP, .NET, various server side technologies are there. But in our full stack development, we are choosing Node.js because we already are very good with JavaScript and jQuery, and we are very good with JavaScript based environments. Because if you want to learn or use any server side technologies like Java, .NET, and others, you need to learn again a language. JSP is a server side technology where you have to learn Java, and they are not simple languages. They are very huge languages. You need to spend 2-3 months of time in understanding those languages. Like .NET uses C Sharp, Java uses Java, JSP uses Java, Python uses Python. So that is the reason. That is the reason. So we are going with a server side tech. We need a server side technology, and we are going with the server side technology, which is very native to us. Already we know JavaScript and we can use that. And it is used at a large scale also. So that means actually Node.js requires a simple JavaScript commands, nothing much required. And we need to just integrate that and use that JavaScript commands actually. So actually Node.js so will run JavaScript code, will execute JavaScript code outside browser. So and sends response to browser. So that is general approach actually how it handles. So Node.js was originally designed by Ryan Dahl, right? So originally designed by Ryan Dahl, and it was introduced in early 2009. So 2009. Uh, Actually, Node.js is completely built with so C++, and JavaScript based environment. That means it is completely built with C++ and JavaScript. It supports all JavaScript based. That means uh, operating system services. So wherever JavaScript runs, this Node.js can work. Node.js have some advantages and some drawbacks also. Node.js have certain advantages and drawbacks. So what are the features of Node.js? What are the features of Node.js and what are the drawbacks of Node.js? We need to understand. That means when compared to other technologies, what are the advantages and what are the drawbacks about Node.js? So technically, and which version of Node.js we are going to deal, that also we will discuss here. Initially, you need to understand what are the features of Node.js. So features of Node.js. So what are the key features of Node.js? Actually, Node.js, when compared to other server-side technologies, so when we compare with the other server-side technologies, some features like Node.js, it uses asynchronous techniques, async model. That means you can simply say that it uses modular approach. Node.js uses a modular approach actually. So Node, it uses a modular approach. Modular approach means that means modular approach is nothing but so only that means here I will give a sub point, right? The library, only the library required for the situation, for the situation, for the situation is used by application, is used by application. So that means it is not legacy type, legacy type. For example, already generally majority of server side technologies are a legacy type. They are a legacy type. Now they are changing into modular type. Legacy type means actually legacy type is nothing but entire library is loaded even to do a small task. You remembered we have used so many things like that. Suppose I am designing a form. I am designing a table. For a table, I want some effects. Then I am using a class called table and table hover class we are using. So these are the CS bootstrap classes we are using. But what we have done is we have imported bootstrap.css. Bootstrap.css. That means you are importing this entire library. It is approximately, suppose, 3 MB. You are importing this 3 MB library to use just only these two options. That means that Bootstrap CSS contains a lot of classes. And you are importing and using those all classes. You are importing and using all the classes. That means technically, so it is a legacy type library you are using. Legacy type library you are using. In the legacy type library, what happens is, generally, entire library is loaded even to handle a small task. Let's talk in a script way also. For example, in your project, you are using, suppose Bootstrap. So we are using a model. So model for dialogue. For creating a dialog box, we are using model. If you remembered, for that actually we were using bootstrap.bundle. We were using bootstrap bundle. So actually, do you know, instead of bootstrap bundle, there is a separate file called model.js. We can use this file. So you observe our projects that we have used, the bootstrap that we have used. Right. Let's open our project here and see. In this project, generally, when you look at this project here, you can observe here the main option is library. So node modules, bootstrap. In the bootstrap, JS is there. In the bootstrap JS, usually in the bootstrap JS, you can see. So that JS contains dist, and you see there all separate files are present. For alert, you have a separate file. For button, separate file. Carousel, separate file. For model, separate file. We have all this. We have all this. So technically, technically, the point is when you are dealing with model, you can just import that model and we can use it. But if I need model and carousel in the same page, then I need to import two files. If I need to use buttons also, then I need three files. Then I need three files, right? That means now tell me what happens if I include such number of files. Is there any problem in including number of files? What do you say? Is there any problem in including so many files? Is there any problem in including so many files? So if number of files are increased, then obviously the page load time also will be increased. Am I right? Right? Page load time also increased. So the problem we learned. Then what is the specialty of this Node.js is Node.js is modular. It uses only the library in the background and it compiles and processes only the library that is required for that situation. That is required for that situation. So in that case, so it is very good. So because it improves the performance, it improves the load time. So this approach, that means actually it uses asynchronous also, I will tell you. So what is advantage is it improves the page load time and response time. So this will be a good option. And remember, currently majority of other server side technologies are implementing this technique now. They are implementing this technique. Then another important point is Node.js is single threaded. This is one advantage and a drawback also. Node.js is single threaded. So with the non-blocking technique, blocking technique. What is single threaded with the non-blocking technique? I will tell you. It is single threaded. Node.js is single threaded. Generally, majority of server-side applications are multi-threaded. They are multi-threaded. So now this is single-threaded. That means generally, what is single-thread, multi-thread? I will tell you here. So it's like options. I will show you like what happens actually single thread and multi-thread. A simple architectural overview. Suppose usually we have different options to handle. Suppose we have several clients. So that means we have multiple clients. Okay, you can, I will just give you here some multiple clients. So we have multiple clients. So this is the client. Okay, client. We have multiple clients. So many clients are present. And all these clients are requesting So all these clients are requesting. So these are the clients. We have the client. Okay. And multiple clients are present. So there are so many clients. All clients are requesting at the same time, simultaneously at the same time. All clients are requesting. So technically, at high level, I will explain architecture also. Don't worry. Usually, what happens is when clients makes a request, this request comes to the web server. So I will give here. We will generally have a web server. The request comes to web server. So this web server is a HTTP server actually. HTTP server. It is an HTTP server. And in this HTTP server, we generally have an application pool. We call application pool. So what happens now? What happens in a single application means a multi-threaded environment. Actually, what happens is, so server will create when request is coming from all these clients. That means all these clients are requesting. So that means all the clients are requesting. So when request is coming from all these clients, when it is coming, all clients are requesting something. That means multiple clients are there, all the clients are requesting something. Then usually what happens is this application pool, we call this as application pool. This application pool, so will create actually, this pool will create multiple threads to handle that request. That means it will create some thread 1. So it will create thread 2. It will create some thread 3. And it will create thread 4 like this. That means it is going to create multiple threads. It is going to create multiple threads. Actually, threads are used to handle multiple tasks actually, because server need to handle multiple tasks now. If server has to handle multiple tasks, then it has to create multiple threads. But one problem here is application pool can create only limited threads, limited number of threads. That means at a time, it can create only limited number of threads. That means application pool can create only limited number of threads. This is very important point. That means it's not like unlimited. It can create only limited number of threads. Better I will keep here inside the pool. It creates limited number of threads. That means there is a limit for the number of threads. Then what happens is, for example, this is the 4 threads that it created. 4 threads it created for 4 requests. And the other requests, so what it will do is, if other requests are coming, because server capacity is 4, then other requests need to keep waiting. That means these 4 requests, for 4 requests, it uses 4 threads. And these threads will handle communication with the server. So that means they will handle communication with the server. The 4 threads are going to handle communication with the server. And they are handling the interaction with the server. And if any another client comes in, that means if any another client comes in, extra client comes in, any other extra clients comes in, then usually what happens is these extra clients are waiting. So these extra clients are waiting. So in order to finish the task, that means in order to connect with the server, if any one of these people are disconnected, if any one of these people are disconnected, then the first one in the queue will come. That means there is a limit. So for the number of requests, that is the traditional how it handles. So thread-based environment, thread-based environment, it will wait. It keeps all the other requests waiting until these are finished. These are finished. This is thread based. For example, you might have seen this in several locations. Suppose you are downloading some videos or some songs. Some websites you can observe. So best example I will give you. You have YouTube downloader where you can download YouTube videos. Have you observed when you try to download the videos, suppose you are downloading a playlist. Playlist contains some 100 videos. Now, all the 100 videos are loaded into memory. All the 100 videos are loaded into memory. But you might have observed only 3 of them are downloading. Only 3 of them are downloading. And others are waiting. All 100 will not start at a time. Am I right? You might have observed that whenever you are downloading, suppose you are downloading 20 videos, one after another you given downloading, but it is downloading only 3. And rest of them it is waiting because CPU have to share the time. The processor have to share the time for all these tasks, and within the time they have to finish those tasks. Within the time they have to finish the tasks. So this is a traditional application. This is the traditional approach. So this is the traditional approach how generally majority of your other server side technologies working. So this is a traditional approach. Traditional approach. So let me give you that this is multi-threaded. Multi-threaded. This is multi-threaded. That is how multi-threads work. Actually, for every task, you need threads. To perform multiple tasks, you need the threads. This is multi-threaded environment. Multi-threaded environment. So this is multi-threaded environment. So generally, the traditional applications use single multi-threaded. But our Node.js uses single-threaded. Single-threaded. That means now what it will do is it will use only one thread for handling all of this. It will use only one thread. It will use only one thread to handle all the requests from the clients. To handle all the requests, it will use only one thread. That means it creates only one thread and it uses only single thread for all of them. So that means to handle all the client requests, now the pool doesn't have any limited number of threads. So that means it will create only one thread. So a single thread. That means only one thread. And with this one thread, it can manage all the requests. That means all are handled by using this one thread. That means there will be no waiting. So that means all can happen simultaneously at the same time. That means one thread object is going to handle everything. This is single-threaded environment. Now, there are some advantages and drawbacks also. This is single thread. This is single thread. This is single thread. So, and generally, so Node.js uses a single-threaded environment. Single-threaded environment. That means it doesn't need the CPU to share the time. It doesn't need CPU share the time. So generally, people call this as it is not CPU intensive. Generally, other technologies are CPU intensive. So that means Node.js is not CPU intensive. That means it need not to, no need to wait. It will. You can simply say that it will not wait. It will not wait. So for it will not wait for a task to perform. So when another task when another task when another task is being performed, so that means it can handle all requests simultaneously at the same time. So this is actually another concept here is so uh, it uses unblocking technique unblocking technique unblocking technique. This unblocking technique makes this so applications very important. Generally, when you are developing an application, unblocking technique means same approaches. Unblocking technique is nothing but generally similar type of concept. Suppose, so we have uh, the server. So we have the web. Means I will just give you here. We have some server, and in the server, so we have some resources. We have some resources, and we need to give access to the resources. So all these resources we need to give access A, some B, some C, D, E. So we have some resources. I need to give access to these resources. They can be audio, video, or some other content they can be. We need to give access to these resources. So client have to access these resources. Then the point is when client have to access these resources, usually how the request is managed is you can see first generally uh, it generally we have two techniques. So this is the client. So client uses synchronous technique. So client uses a blocking technique. Generally in blocking technique, what happens is so a request for A will go. So request for A will go, and it will wait for response from A. So that means it will wait for response. So wait for response. So response from A. Wait for response from A. After the response is finished, so that means wait for the response from A. After A successfully responded, that means response is finished. Then it will go for B. Then it will make a request for B. That means after response is finished, then it will make a request for B. So request B. So it will make a request for B. And it is making a request for A first. That means after response from B finished, then it will go to C. This is a blocking technique which many technologies usually follow. Blocking technique which many technologies follow. That means all other technologies use this blocking techniques. Blocking techniques. This is a blocking technique. Unblocking technique is similar to this. Unblocking is similar to this. But the key point is in unblocking technique, after making a request, so it is making a request to A. After making a request to A. So this is unblocking technique. After making request to A, it will not wait for response from A. Automatically, it will make a request for B. It will make a request for C. It will make a request for D and E. It will make request for all. And it is not waiting for response for A. Whichever response is ready, that response will load first. That means B may load first, C may load first, D may load first. That means it will perform requests to A, B, C, D, E, C, D, E, all at a time. Simultaneously, it will make a request. It requests all of them. It requests all of them. The request will go for all of them. For all of them. And whichever response is ready, that response comes. Response comes. This is unblocking technique. That means it will not wait for that particular response from one. So it will simultaneously make everything. Best example I will show you. This is unblocking technique. I will show you this practically. Means practically we will see how they work actually. We will see practically how they work. Right? How they are going to handle that. We will discuss about it. So technically, now the point is here. Generally, we can see best example. Suppose you have WhatsApp. In WhatsApp, so you are offline. So in WhatsApp, you are offline. And so, some of your friends sent you some messages. In WhatsApp, they sent you messages. Messages like first, suppose at 9:20 a.m. they sent a picture to you, and at 9:22 so a.m. they sent a video to you, and at 9:30 a.m. they sent some text message to you. These three messages they sent to you, but you are offline, and suddenly you are so online. So you are online now. When you are online, now tell me which message will first come to you. Which message will first come to you? Yeah. Actually, what happens is, you might have observed. So all three messages will come. But you will see that text is visible immediately. Picture is loading. Video is also loading. Am I right? All the three are pushed to you. Am I right? All the three are pushed at a time to you. Okay, all the three are pushed to you, but you are saying text because you can see text immediately because it is lightweight. Am I right? It is immediately lightweight. Now tell me, so will picture load first or video load first? Will picture load first or video load first? So text first appears, but it's sent at 9:30. Picture or video, which will load first, it depends on the size. Am I right? It depends on the size. Right? Based on the size, it loads. It's not like this one will be first size. That means if picture is very large, sometimes it can be 3-4 MB. Video is less, then it will load first video. It depends. It depends on that, right? Right. So technically, so if all are pushed to you at a time, if all are pushed to you at a time, and they are loaded, which one is loaded first? It depends on technically it depends on the size. Is it lightweight or not? It depends on the size. Depends on the size. So that is the reason. So usually we need to understand. We need to understand some options. So technically, uh, based on the requirements, we need to use the server side technologies. This is okay. This is good. This is good about Node.js. So it is a single threaded environment. It uses modular approach. It uses non-blocking unblocking techniques. It uses unblocking techniques. Technically, one more important point about Node.js is Node.js actually. So another feature of is will not Node.js will not use buffering, means will not use caching, will not use caching. That means the advantage of this is data data is sent in the form of packets. Data is sent in the form of packets, which you will learn. I will tell you what does that means. I will tell you. So it is sent in the form of packets. Data is sent in the form of packets. So that means data will not buffer. So data will not buffer. So continuous access to data, continuous access to data. So continuous access to data, access to data. These will be so good advantages. Good advantages. That means actually one simple point I will tell you. The best example is YouTube. You are watching YouTube, and YouTube, you might have observed in the early days, few years back, when you are watching YouTube and you want to watch a video, that video is 1 hour. Do you know we can pause the video and let it buffer 1 hour? After that, even when you are not connected to internet, you can watch that paused 1 hour video. Do you know that? In the early days of YouTube, you know that? Have you experienced that? That means in the early days of YouTube, we can pause entire YouTube video, and you can watch it even when we are not connected. Now, is it possible? Now, is it possible? Now, is it possible? No, you pause YouTube video, it will pause at the same place where you have paused. Just 1-2 minutes, it can buffer. And after that, it will stop. It will not buffer the entire rest of video. Am I right? Right? It will not buffer the entire video. This is because it is using Node.js. YouTube uses Node.js. And observe carefully, it will not buffer. Early days, it used to buffer. Now you can observe that if the internet connection is slow, then automatically it will try to change the quality of video and send the video to you. Am I right? That means if internet connection is slow, then bytes receiving is slow, then it will change the quality of the video. But it will not stop the video generally. If very slow, then it can stop the video. But if it is slow, bytes receiving reduced, then it will change the quality of the video. You might have seen this in Netflix. You might have seen this in Amazon Prime, YouTube. All these are using Node.js. All these are using Node.js. Streaming applications, data streaming applications are majority using this Node.js. So Node.js is good. Node.js is good for you call IO bound applications, input output applications. So I will show you them. Data streaming applications. So applications and non-CPU intensive applications. Intensive applications. So, and it is good for non-CPU intensive applications, right? And it is good for single page applications, SPA. It is good for progressive web applications. These all, for all these in the backend, Node.js is good. Now Node.js, so Node.js is having some drawbacks also. That means if it is not good, that means so Node.js is not good for relational data interactions. Relational data means lot of relational data interactions, and CPU native, CPU intensive applications. So intensive applications. So applications, that means multi-threaded applications, multi-threaded environment. So multi-threaded environment is very much important, and sometimes multi-threaded environment is required for handling multiple tasks, right? And large scale e-commerce applications, because they need relational data interactions actually. You may ask, that means if millions of people are trying to interact, and for every user we need to maintain separate memories, so threads, and to manage their tasks, because every user has a lot of interactions. In that case, Node.js will not be great. It will fail in those situations. You may ask, like Netflix, YouTube, millions of people are watching. But millions of people are not interacting like they are not searching, they are not adding to shopping cart, they are not browsing, filtering, sorting. They are just watching. They are just streaming the content. They are not handling interaction. For every user, I need to maintain a separate shopping cart, separate filtering options, separate searching options. So I need to maintain separate threads for them. In that case, Node.js is not good. But for other type of applications, so Node chatting applications, data streaming application, audio video streaming applications, for all these kind of applications, small scale database applications, all these applications, Node.js is good. That is the reason, depending on their requirement, they choose the server side technology, which one they want, right? That is technically Node.js. Just overview about what it is. Now, how Node.js works, practically how we have to use Node.js, we will see that. That means writing the Node.js programs, compiling, running the Node.js programs, how to write server-side scripting. That we will see in our next session. Tomorrow we will see that, right? Tomorrow we will start practically working with Node.js, okay? Right.